How's it going, everyone? It's Kyle here with another C programming tutorial, and in this week we're learning about loop control structures. Last week we learned about our first control structure, the if-else statement. This week we're learning about three more which fall under the general category of loops. So we have the while loop, the do-while loop, and the for loop, all of which are a means of which you can use logic to control how many times some set of instructions is executed in a program. So without further ado, let's go ahead and learn about them. It's time to jump into programming some control structures. This is where it gets really exciting because this is where the meat and potatoes of coding actually happens. The control structures are used to, as you can probably guess, control your program's execution. And they're very important because this is pretty much how you get your program to do whatever commands that you want it to execute in a specific order. So the first thing I want to do before we look at any control structures, since most of these control structures require some kind of condition, I'm just going to define a variable. So let's say I have some condition. I'm just going to give it some value of 0. We could also have a logical value. So let's call one logic, and we'll just set this equal to either true or false. Doesn't really matter because I'm just using this for an example. So these are the variables that we'll use so I can show you some sample conditions for control structures. Anyway, the first control structure that I want to look at, or actually the first collection of control structures, are all loops. And the first of the loop control structures that I want to show you is the while loop, because it's really quite simple. So you simply type while, and you have to give it some kind of argument in parentheses, so some kind of condition. And then after that you'll have the body, which you outline with these curly Q brackets just like you did with a task. And in here you could do your commands and have it do something. So anyway, the way that a while loop works is that while the argument in here is true, it's going to continuously loop and execute all of the commands in here. And then as soon as this condition turns false, it's going to break out of this loop and then move on. So what a sample condition could look like, so let's say if I have my condition, so my variable condition is greater than -2, for example. So if this was a changing variable here, so if this was controlled by some sensor reading, I can have it so this while loop will continuously loop while the value of this variable is greater than the value that I set, and it'll keep returning true and allow it to continue looping. Then once this value gets really low, so either equal to or lower than -2, then it's going to break outside of that loop. We could also do this with a logic value. So let's say I had a logic value, like if this Boolean variable was attached to a button where pressing the button would give you a true value and releasing it would give you a false value. Then as I'm holding down this button, my logic variable is true, so this while loop will continuously loop, and as soon as I release that button, then the program is going to jump out of the while loop and move on. One final thing I want to show you with a while loop is these are used to make infinite loops, and the way you would do that is you simply type true into the argument. Now what this is going to do is this loop is going to loop indefinitely because we've always set the argument to be true. And this is how you do infinite loops within your main task. And this is a programming practice that I end up using a lot. So for example, if I'm programming a remote control car, I want the program to continuously loop and not stop until I press an external button. I'm going to use a while loop with true in the argument. Anyway, so that's how the while loop works. There's also a slightly different variation of the while loop called the do while loop, and I'll show you what that looks like. So you start by typing type do, and then outline the body of the body in curly Q brackets, and then you can put your commands in here, so have it do something, and then every do must be followed by a while statement. And this is where it's similar to the previous while loop, and you'll enter an argument with some kind of condition. So if I had condition is greater than 0, for example, the way it works is pretty similar to a while loop. The key difference is because we've put the statements before where the control structure is checking its condition, it's always going to run these commands that are defined in here at least once. So with your standard while loop, if, for example, if whatever value you're comparing is already false, it'll never execute anything within the while loop, and it just simply skips completely over it. Now with the do while loop, even if this condition is false, it's still going to be able to execute these statements at least once. And that's just a slight difference between the two. Otherwise, it works pretty much like a regular while loop, where if this condition is true, then it's going to continuously loop these statements and play them over and over again. I personally I don't think I've ever used a do while loop, but there are plenty of applications where you might find yourself needing to use one as opposed to the standard while loop. And then the last loop that I'm going to go over is what's called the for loop, which is very, very powerful. I end up using it in almost every project I do, because it's a while loop, but it has functionality built into it to control the looping precisely. So you're going to type in for, and then in the argument we actually have a few special things to type. So the first thing you're going to want to do is define a variable. The easiest one to define is just I. We're going to set that equal to 0, and then put a comma. The for loop will have 3 arguments that get input in these parentheses, and then I is less than some value, so I'm just going to say 5, and then one last comma, and then I with the increment operator. Remember that we learned about this increment operator back a few tutorials ago. And then you can give this control structure a body, and you'll be able to put statements in here, so tell it to do something. So this is yet another loop, but now what this is this is a special type of while loop that's specifically for controlled looping for a certain amount. So what we've done is we defined a variable I, and we just said it equals 0. And while I is less than 5, we're going to keep looping around. But each time the loop completes, it's going to increment the value of I by 1. So what the consequence of this is this loop will run exactly 5 times. So it's going to run these statements in here 5 times, and then after that's happened, it's going to jump outside. You can also nest for loops within each other, which is how more advanced and more complicated programs start to take shape. But this is the for loop. It's very compact and elegant. It is possible to get a while loop to have the same functionality, but it's not quite as concise, and it'll look a little bit sloppier. And for that reason, it's preferred to use a for loop for things like controlled looping. Let's take a look at what the for loop looks like in the context of a real program. And this is a program that I had made for a GPS project that I was working on. And what this does is it takes an average of 625 GPS values over the course of, I think it was 3 hours if I remember correctly. Anyway, so we can scroll down to our main task, and we can see 2 for loops. So there's one inside of one inside of another, and they're defined by these variables: period number and array size, which I think for most intensive purposes were 25. And you can see that I've placed one for loop inside of another for loop. So what this functionality means is that as the program executes down, it'll enter this for loop and then immediately enter this for loop. So this one will repeat for 25 times, and then when that's finished repeating, it's going to exit, but now it's still within this for loop, which tells it to go back. So this one repeats 25 times, then is caused to repeat its 25 times again by this loop. And what that means is overall it's going to end up repeating the code that's in this inner loop 625 times. And there's a specific reason why I decided to nest them. I don't remember exactly what. It's been a while since I worked on this project. It's from 2016. But an important thing to note that when you're nesting for loops is that you can't use I for both of them. Otherwise, the iteration is going to get messed up. So you can see here, I used J for the outside and K for the inside. You can name these variables whatever you want. It just looks cleaner when you choose a single letter. But make sure that these variables are 2 different things. Otherwise, the iterations of the loops are going to get all wacky, and then your program won't work anymore. Thank you for watching my tutorial this week. If you haven't already, click here to check out my new book. It's called Building Smart LEGO Mindstorms EV3 Robots, and it's now available on Amazon. If you found this video helpful, be sure to subscribe to my channel for more tutorials like this every Thursday. And if you have an idea for a tutorial, Drop your suggestion in the comment section below. Thank you for watching, and I'll see you next time.